Alright, today we're starting Module 2, talking about angles and geometric figures. So to start off with, we're going to just touch on what a ray is. A ray is a part of a line. It continues forever in one direction, beginning at the end point. And we name it using two capital letters. The first letter is the end point. The second letter is a point that the ray passes through. When we name a ray, the arrow symbol always points to the right. So, for example, in this diagram on the left here, we have letters A, B, and C, points A, B, and C. So we can call that ray AB, or you can call that ray AC. We always start with the letter that it ends, or the end point of the ray. The ray on the right with points R, T, and U, we can call that ray UT or ray UR. Again, it doesn't matter what direction it's facing, the arrow above the rays will always point to the right. Now, two collinear rays with a common endpoint, we call those opposite rays. Opposite rays form a straight angle, and straight angles are like straight lines. They have a measure of 180 degrees. So in this example, ray BD and ray BC are opposite rays. An angle is a pair of rays that have a common endpoint that we call the vertex. In this picture, A is the vertex. And we can name angles several different ways. One way is just by using one capital letter, and that must be the angle's vertex. So in this case, we call that angle A. Another way is to use three capital letters where the vertex is in the middle. So we could call this angle DAB or DAC, or we could call this angle BAD or CAD. Okay, so A is always in the middle. Now, if there's more than one angle at a vertex, we have to use three letters. We can't do the option of using the single letter to name the angle. So, oh my goodness. Sorry, I don't mean to keep doing that. If there's more than one angle at a vertex, we've got to use three letters to name the angles. We cannot use the name angle D in this case because others won't know which angle we're referring to, right? There's three different angles. We could call that angle ADB, we could call that angle BDC, or we could call that angle ADC, but we could not call that just angle D. Now, interior and exterior, very important that you understand that concept. Points G, F, and H are interior because they lie on the interior of the angle. Points I, J, and K lie on the exterior of the angle, right? So they're outside the angle. Now, we're going to trace these angles on the page here. So, angle AGB. So, angle AGB is found right there. G is in the middle always. DGP in this next one. So, DGP. It's right there. Angle AGD, angle AGD, and angle CGE, CGE. There we go. So we're going to name all the angles that has D as a vertex. Well, of course, we could call that angle 6, angle 7, angle 8, angle 9, and angle 10. All those have D as a vertex. We could also name those, I need to put the angle sign there. We could name those after the points of the, so we have angle CDB. And of course we could name that angle CDF as well. And of course you could reverse those too. You can call that FDC or BDC. All right, next we have BDE. And of course we could call that FDB as well, or FDE, excuse me, angle FDE. All right, we have angle FDG. We have angle GDH. Let's see, we also have angle EDH. And we also have angle BDH. And we even have angle CDH. There's a few more that we could name, but there's just a ton. So we're just going to stop right there. All right, a point that's on the interior of angle FDE. A point that's on the interior of angle FDE would be point A. That's on the interior of point FDE. And all the points that are exterior to angle FDE are going to be these 3 points right there. So we have point C, point H, and point G. Now, angles that have the same measure, I want you to understand, angles that have the same measure are congruent. Just like segments that have the same length are congruent, angles that have the same measure are congruent. And arc marks are how we show when angles are congruent. Just like in the segments, the tick marks that we used showed those were congruent. Arc marks show that angles are congruent. So angle QTR is congruent in this picture to angle STR. A ray or segment that divides an angle into two congruent parts is an angle bisector. So in this picture, ray TR bisects angle QTS. So that means that the measure of angle QTR is equal to the measure of angle STR. So using that knowledge, we're going to understand some things here. Ray BD bisects angle ABE. So that means that ABD is congruent to EBD. And I also know that ABD is 4x plus 14. And I know that DBE is 8x minus 32. So, since those are congruent, right, angle ABD is congruent to angle EBD. That means that the measure of angle ABD is equal to the measure of angle EBD. And I know the measure of ABD is 4x plus 14. So that means it's equal to the measure of angle EBD, which is 8x minus 32. So by setting those equal to each other, subtract 4x from both sides. I can also add 32 to both sides. I get that 4x is equal to 46. So I divide both sides by 4. I get that x is equal to 23 over 2. Or you could simplify that to 11.5. Now, what they're looking for is the measure of angle DBE. So we got to plug that back in. Eight times 11.5 is 92. And 92 minus 32 is 60. So, therefore, the measure of angle DBE is 60 degrees. Alright, so number 6. In this figure, ray KJ and ray KM are opposite rays, and ray KN bisects angle JKL. If the measure of angle JKN is 8x minus 13, and the measure of angle NKL is 6x plus 11, find the measure of JKN. So, with it being a bisector, that means that it's going to cut those in half. So, this angle JKN is congruent to angle NKL. So, that means that angle JKN is congruent to angle NKL, which means the measure of angle JKN equals the measure of angle NKL, which means that the measure of JKN is 8x minus 13. That's equal to 6x plus 11, which is the measure of NKL. So we can subtract 6x off of both sides to get 2x. We can add 13 to both sides to get 24. And then we can divide both sides by 2 to get 12. So x is 12. But what they're asking for is the measure of JKN. So that is equal to 8 times our x, which is 12, minus 13. 8 times 12 is 96. And 96 minus 13 is 83. So the measure of angle JKN is 83 degrees. Adjacent angles are two angles that have a common vertex and a common side, but they have no common interior points, and they are next to each other. All right, so they're neighbors. Just like you have neighbors, angles can have neighbors, and they are adjacent angles. A linear pair is a special kind of adjacent angles with non-common sides that are opposite rays. The sum of the two angle measures is 180 degrees. Okay, so in this picture, 45 plus 135 equals 180. You can see that angle CBA and angle ABD combine to make a straight line or an opposite rays from ray BC and ray BD. Now, vertical angles are the two non-adjacent angles. So non-adjacent means they're not next to each other, formed by two intersecting lines. And vertical angles are congruent. Please make sure you remember this. Vertical angles are congruent. Most important thing you can learn from this lesson. Vertical angles are congruent. So in this picture, angles 1 and 3 are congruent, and so because they are vertical. Angles 2 and 4 are vertical, so they are congruent. Think about a bow tie. A bow tie, each side of the bow tie is congruent. So that means like each side of the bow tie is the same size. Those are vertical angles formed by the center of the bow tie. So in this picture, angles 2 and angle 3 are vertical angles. Angles 3 and angle 4 are adjacent angles because they're right next to each other. Angles 1 and angle 2 form a linear pair because together they form a straight line. If the measure of angle 2 is 114 degrees, then that means to find the measure of angle 1, I can just take the 180 degrees that's formed by a linear pair and subtract the 114 that measure of angle 2 has, and what's left over should be 66 is how many degrees are an angle 1. Now, angle 3 I can figure just by knowing that vertical angles are congruent because I already know 2, so therefore angle 3 should be 114. And the measure of angle 4 is also vertical to the measure of angle 1, so that means that it's 66 as well. So in this picture down here at the end, number 11, name a pair of vertical angles. Well, we've got a couple of options. So we could say angle ALR and angle XLW. That's vertical angles. You could also do angle ALX and RLW. Those are also vertical. A pair of adjacent angles, so that means they're angles that are right next to each other. So we could say angle, oh, that looks kind of more like a greater than sign, so let me fix that. Angle NTY and angle YTG. Those are adjacent because they're right next to each other. There's lots of options that we could put there. An angle congruent to angle JBE, well, vertical angles are congruent, so if JBE is a certain measure, that means that angle VBM should also be the same measure. All right, so that's it for today's notes. If you have any questions, please shoot me an email. or send me a message on Canvas. Have a great day.